Hello, this is Mr. Henry, and welcome to lesson 3.4, Finding Missing Parts of Similar Figures. So the central question says, how do I use properties of similar figures to find unknown sides and angles? Did you know that you can find the height of any object outside as long as the sun is shining? All you need is a measuring tape, a friend, and you'll see an example too. Well, the sun has to be casting a shadow. So this trick actually works for buildings, flagpoles, trees, or anything as long as you can measure how long its shadow is. So, for example, if you wanted to measure how tall, say, this cheerleader was, if you could measure her shadow and the shadow of, you can figure out how tall the cheerleader is. If you want to know how tall, like the uprights on the football field are, the field goal posts, if you measure its shadow and her shadow, and if you can figure out how tall she is, there's a little proportion you can do that you can use to figure out how tall the flagpole is, because the angle up here will always be the same because the sun's in the same spot for both of you, which makes these sides all proportional. So you can use a proportion to find the missing side of a similar figure. So you can find the height of a tree, a mountain, the school, anything that's really, really tall. So let's see some of that as we go through the lesson. There is no new vocabulary. We've already covered the vocab for this lesson. Things like similar figures, we'll be talking about them quite a bit. Corresponding parts, we talked about them already. So if you need a refresher on similar figures or corresponding parts, go back, look at your vocabulary cards, and let's get started with the lesson. So here in example A, it gives us triangle LMN and triangle XYZ are similar. That's what this little doohickey here means. This little symbol means similar. So they are similar. What is the measure of angle X? So we're looking for this piece right here. There's our question mark. Well, since the angles are similar, we know that this is a right angle and that's a right angle. I mean, they're both in there. We know that since this is 52 degrees, this is 52 degrees. And then all we need is that background information that we used in the last lesson, that all the angles of a triangle add up to 180 degrees. So 52 plus 90 plus x equals 180. That gives me 142 plus x equals 180. And if I subtract 142 from both sides, x should give me 38. 180 minus, what was the number? 142. 38. So this angle X was 38 degrees, which outside the question, but we could also tell that this angle L is also 38 degrees, which is another way we could have done this problem. We could have figured out what all the angle measures were here, and then just kind of pop them over to their corresponding parts in XYZ. Angle measures are the same in corresponding parts of similar and congruent figures. Letter B. We need to find, it says here, well, triangles DEF and RST are similar. Cool. Find ST and DF. So we need to know what this is and what that is. Okay. Now, the way we did this before, if we had all of the parts, we would plop them into a proportion, we'd cross multiply, and that would check to see if they're similar. Now we know they are similar, and we're going to use that proportion again to find our missing pieces. Let's start with X. So I need to have a pair of sides that are the same. or that I know the relationship between them. So for example, from 12 to 20, 12 to 20, there's a relationship there. There's a scale factor, some number. I could figure it out, but I don't care right now. But that relationship there is going to help us find the other part. So for example, now I have 12 corresponds to 20, and 9 corresponds to x. Look at that. I have a proportion with one variable. I can cross multiply and solve. That gives me 12x. That's 180. Divide both sides by 12. Clear. 180 divided by 12 equals 15. So this missing side here is 15. Let's pop him in. 15 centimeters. Okay, so now we have that part done. We need to find what this side df, my variable y, is. And we can do the exact same thing. I can set up almost the exact same proportion. I'm going to relate 12 and 20. 12 corresponds to 20 the same way that 10 and y correspond. So 12 to 20, y to 10. And we cross multiply, and we're going to get our answer. Let's see. That times that is 120. That times that is 20y. Divide both sides by 20. And y equals 60. That seems really far off. Ah, stupid zeros. I have an extra zero in there I don't need. It's 6, not 60. So my missing side, that makes more sense to me, should be 6 centimeters. And there we go. We use proportions to find our missing side. Letter C. It says ABCD is similar to WXYZ. These appear to be just some random quadrilaterals. Find and label all missing angles. So if you could please right now, pause the video, try this problem on your own. Try to find what all of these missing angles are. Alright, so let's see. Well, it looks like this Z and this D are corresponding angles. They look to be in the same position, the same type of angle. Did you know you can actually use this name to help you? This naming mechanism actually has to be done a specific way, where the first letter corresponds to the first letter. So A and W are pairs. They're matching. They're corresponding pieces. D and Z are corresponding pieces. So my assumption that Z looked kind of like D, they look about the same, was actually true. Those two angles are corresponding, which means they are congruent. Angle Z is 40 degrees. Okay? And since now we know that A and W are the same, this angle A would be the same as angle W is 52. Alright, so I need to find C. C corresponds to the third letter, Y. Y is 133, so is C. Okay, so now we have just this last pair of angles, this X and this B. X and B are both corresponding, or they correspond to each other, so that doesn't help me out because I'm missing both of them. So what knowledge do we have that could help us find that missing angle? This, hopefully, is some background knowledge that you already know. Did you know that all of the angles of a quadrilateral, a four-sided figure, if you add all of those internal angles together, they should always equal 360. So if I take my missing angle x plus 52 plus 133 plus 40, I'm doing this quadrilateral here, so x plus 52 plus 133 plus 40, all of those together should equal 360 degrees. So let's solve it. What is my missing piece x? I combine those things together, clear, clear. 52 plus 133 plus 40. Is that right? 52 plus 133 plus 40. That makes more sense to me. 225. And then solve the little dinky equation. Subtract by 225 on both sides. And x equals 360 minus 225. 135 degrees. So that is my angle x, 135. That's the missing piece needed to make all four of these add up to 180. Since angle x is 135, and its corresponding angle b is also 135. Corresponding angles are congruent. And there we go. We found all of the angles for both figures. Letter D. Here it says, find all missing sides of both triangles. So we need to know what is, well, I could just label them as like X, Y, Z, or A, B, C, or whatever naming you want to use on them. I'm going to avoid X, Y, Z because of this X, Y, Z. So we'll call it A, B, and C. You can call them whatever you like, but please pause the video and find all three of them to the best of your ability. Okay, so using similar figures, we can find this letter C. I'm going to start there because I see that this side length of 8 and it corresponds this side length of 36. And 6 would correspond with this C, and that's a proportion. 8 corresponds with 36, 6 corresponds with C, a little cross multiply action going on here, 8C, and 36 times by 6. 216. Divide by 8 on both sides, and C equals 216 divide 8 equals 27. Does that make sense? Yeah, it looks like it fits roughly in the picture. So this angle C, I now know is 27 inches. All right, one angle down, two to go. What knowledge do we have to help us find these other two angles? Because both, the side lengths, side A and side B are both corresponding to each other. And so if I find one of them, I can easily find the other using a proportion. So I have to find out what one of these angles are. Do you see it? Both of these triangles are right triangles. Right triangles, if we're trying to find a missing side, we use the Pythagorean theorem. So Mr. A squared plus B squared equals C squared is coming back out. I'm going to do the smaller one. Remember that this side is the hypotenuse, so no, I'm not going to plug in A for A. This is my missing piece over here. The A and the B are the legs, this 8 inches and this 6 inches. So 8 squared plus 6 squared equals, oh fine, I'll call it A squared, because that's the variable I have here. 64 plus 36 equals A squared. 100 equals A squared. And that means that A, if I square root each side, equals 10. All right, 2 down. I know that this side is 10 inches. Now we just have to find this letter B. And we have two ways we could go about this. We could go about this using proportions because these shapes are similar. And now that I know that this is 10, I can set up a proportion comparing this side to this side. Or this other triangle here is also another right triangle. We could use the Pythagorean theorem all over again using 36 and 27 for the legs and find a hypotenuse. Both ways should give us the exact same answer, so it's really up to you. I'm going to use similar figures. I'm going to use proportions since that's kind of the point of the lesson, I guess. So 8 corresponds to 36. See? 8 corresponds to 36. And 10 corresponds to B. And then a little cross multiply action going on here. That's 8B. That is 360. Ooh, I could do that one in my head. Divide by 8. Divide by 8. I lied. I can't. 45. 3 clear. 360 divided by 8. Haha. 45. So my missing side length of B is now 45 inches. And I think we've now answered the question. The question was to find all of the missing sides of both triangles. I now have every single side filled in. I found this 27 using proportions and similar figures. I found this 10 using the Pythagorean theorem because this is a right triangle. And then I found the 45 using similar figures and proportions. Remember how I said those Pythagorean theorems are not going away? They'll be around the whole year? Well, still true. Here we go. Some applications now. This problem says Miguel is trying to find the height of a flagpole in front of the school. The sun shines on Miguel and the flagpole at the same angle, casting shadows and making similar triangles. Miguel listed the measurements he knows in the sketch below. How tall is the flagpole? This type of problem actually does work in real life. You can actually do this same exact thing. You can measure trees, you can measure how tall buildings are, flagpoles, anything that casts a shadow, that you can measure the shadow. You can actually do this same bit of math. So because these two triangles are similar figures, because the sun's angle, this angle here should be pretty much the same no matter what figures you're measuring. And that would also make that these bottom angles here would be the same. So these are similar figures. So now what we have to do is use our knowledge to find out how tall this flagpole is, this missing piece. I'll label it as X. Well, side lengths, proportions. Similar figures are proportional in size. So 5 corresponds, X corresponds to 5. X corresponds to 5. 17 corresponds to 3. And if I cross multiply here, 3 times x is 3x. 5 times 17 is 50, and 35 is 85. 5 times 17. And now to solve our proportion, we divide both sides by 3, and we get x equals, well, whatever 85 divided by 3 is. 85 divided by 3 equals 28.3 feet. So this flagpole is 28.3 feet tall. And we were able to figure that out because of similar figures. Letter B. In a scale drawing of a sailboat, the mast is 18 inches tall and the boat is 5 inches long. The real boat's length is 42 feet long. If a triangular sail stretches the length of the boat and the height of the mast, what is the area of the sail for the real boat? This sounds like we need a picture to help me understand what's going on here. So I need a boat. So I've got my fake boat, and I've got my real boat. All right, let's see. The mast is 18 inches tall, 18 inches tall, and the boat is 15 inches long. 15 inches long. Okay, so that's my fake boat. The real boat's length is 42 feet long. Okay, so that's 42 feet. If the triangular sail stretches the length of the boat and the height of the sail, what is the area of the sail of the real boat? Okay. So the question I'm looking for is I'm trying to find the area of the sail. This area of the sail would be a triangle. It's a triangular sail. So the area of a triangle is 1/2 the base times the height. Okay, what stuff do I know? So 1/2 is just 1/2. The base would be this bottom side. So the base here is 42 feet. The height of the sail, I don't know. That I need to figure out. I don't know how big this sail is in real life. I know how big it is in the drawing, but not on the real boat. So I have to do some math in order to find the height, to plug it into the formula to get my area. Now the math I would need to do to find this height, I've got similar figures. See, scale drawings make similar figures. These are similar figures, so I can use a proportion. 18 corresponds to x. 15 corresponds to 42. Cross multiply here. 15x and 18 times 42. 756. Divide both sides by 15. Gives me x equals 50.4 feet. So the height of this sail, the missing piece here, is 50.4. That's the information that's needed for here. 50.4. Now I have all the information I need to answer my question. So let's just do it. Area equals 1/2 of 42 is 21 times by 50.4, and the area is 50.4 times by 21 is 1058.4 feet squared. And there we go. We've now found the area of the sail of the real boat using the area formula. We had to find what the height was because it wasn't given in the problem. We found the height because these are similar figures. We used a proportion. Let's see. Jose and Alicia are trying to solve the problem below together, but disagree on how to solve it correctly. Determine who has the correct method. Explain why the person with the wrong method is wrong. So you have the image on your paper. You do not have this, what I have in blue, the descriptions of what each person believes. So here it says that triangle ABE and ACD are similar. So this small triangle and the large triangle are similar. Jose believes that this x is equal to 10 because it fits the pattern he sees in the picture. He sees AB is 5 and BC is 5. AE is 4, ED is 4. CD is 10, therefore BE is 10. Alicia believes that the measure of this x is equal to 5. And it says she set up a ratio AB over AC, got 5 over 10, and found a scale factor R equals 1/2. So 1/2 times 10 is 5. What I'd like you to do is, again, determine whose method is correct, and then for the person who is wrong, explain why that doesn't work. Why is that wrong method wrong? Go ahead, pause the video, and do that right now. Okay, so hopefully you found that Alicia is correct and Jose is wrong. Now, first off, why is Alicia correct? Well, Alicia's correct because if you set up this ratio AB to AC, the small triangle to the big triangle, you get 5 over 10. This is true. And so the ratio from the small triangle to the big triangle is 1/2. Therefore, half of 10 is 5. That is correct. That is one way of doing this. You could have also, maybe on your own, set up a proportion and said, okay, well, AB over A, or AB to A, was that C? Yeah, AB to AC. So this side to this whole side, which is the 5 to 10, and then pick another side. Maybe this here, BE, would correspond to CD, x over 10. And if you cross multiply, you get 50 here, you get 10x here, divide by 10, x equals 5. So you could have verified that Alicia had the correct method without even doing it her way, with doing it another way. So she is correct. So the question then comes down to, why is Jose wrong? What did he do that was so wrong? Well, in Jose's method, he wasn't really looking at similar figures. He's just looking for number patterns. And he saw 5 and 5, 4 and 4, so 10 and 10. But let's see if that makes sense. This side, AB, is 5. No doubt about that. But this 5 centimeters here, what is that measuring? It's not measuring the length of this big side of the triangle. It's measuring just this section of that side. So the whole length of this triangle is actually 10. So if he would have saw 5 goes to 10, and then on the bottom, same deal. This is definitely the length from A to E. But this 4 centimeters is just this section of this side of the triangle. So if he would have related it as AE is 4, and then the whole side, 4 plus 4 is 8, he might see that what you're doing is you're taking the small triangle and multiplying by 2. Then you might be able to figure out, oh, so some number times by 2 gives me 10. That number has to be 5. Also, I don't think it would make sense if these two triangles are similar. If you look at what the actual side measurements would be, so ABE, he thinks is 5, 10, and 4. First off, that's not even a triangle that can exist. Remember how we said the longest side of a triangle cannot be bigger than the other two sides put together? A 5, 4, 10 triangle doesn't even exist. It cannot be put together. Those three sides won't match up. Also, we have now a 5, 4, 10, which doesn't exist, and the big triangle would be a 10, 10, 4. I'm sorry, 10, 10, 8. And just by looking at those two do not appear to be similar. 5, 10, 4, 10, 10, 8. If they're similar, they should be congruent, or they should be proportional, and it doesn't work out. So there's many reasons why Jose is wrong, but the point is we found out who's right, who's wrong, and we found out why to explain to Jose why his method doesn't work. Alright, so for our summary here, we have a type 1, it's 2 minutes on the clock, and it says, how are dilations, similarity, and proportions all related? So those three topics, dilations, which we talked about a lot earlier, the fact that tooth shapes are similar, and proportions, or proportional, how are all of those phrases, all those vocabulary words related? Because they are. They all kind of go together, but I want you to describe how. Show some connections between them. Okay, go ahead and pause the video, answer the question. This has been lesson 3.7. Thanks for watching.